I don't know the connection between those two, but I know it's actually, I would say it's closer to Parkinson's disease. So just like I was saying, technically our motor neurons actually tell how we move. Like, you see your lips when you move it, your brain sends a signal to your mouth and makes your lips actually move while you're talking. Also, your muscles in your arm is the same signals that's being sent through your entire spine to your leg and to these parts right here. So this is technically the bilateral human being. Do you guys know what C. elegans are?
What?
C. elegans. Synapse. I can't pronounce that word, so I'm gonna let that one go. I'm gonna let him pronounce it because he knows how to pronounce it very well. It's C. Can you pronounce it for me?
It's C.A.
Pronounce. C. clinalis. I will try to pronounce it. You will see the spelling soon. You will see the spelling soon. So technically, see what I was talking about? You were talking about this, right?
Me?
Yes.
Yeah.
Yeah, so that's what happens in MS. So it's very similar, but I would assume that Parkinson's is actually much similar. This was just what I showed earlier. So these are different stages of the disorder. The ALS is the most known in America. The primary lateral sclerosis. There you go. And the progressive bulbar palsy. These are all disorders on the same level as motor neuron. On the same level as motor neuron. Okay. I hope this one works. So I'm just going to show you guys a quick video of what it actually does. Please work. Did not work.
I have been living with motor neuron disease for 5 years now. This deadly disease takes your whole life from you, leaving a perfect mind. In my case, my triple F boys and wife drive me to keep going. I rely on care 24/7, but with a few close friends helping me to build and adapt environmental controls. For my eye gaze, I can operate my own bed. Heater. TV. Music system, and even fix my son's computer when it goes wrong. Depending where you live in the world or you talk to, you will hear it called motor neuron disease, MND, Lou Gehrig's disease, or OLS. Even now, in 2012, we still don't have a cure for this deadly disease for patients like me, but still I remain an optimist. I have done this video to show people that life is not over until the heart stops.
So you guys saw that video, right? Did you guys see how he couldn't move? And now they have to use special technology just so he could use only his eyes to be able to move everything else that he couldn't be using. So how lucky do you feel right now to be able to be moving every day? So this is also part of the reasons why I also got into technology, to see how to use technology to make people's life easier. Like, look at him now. Everything else that was being done for him by a helper is being done by him using technology. I'm gonna go back. So there comes that big word again. That's what a sea elegant is. And that's not a snake, it's not disgusting. It's pretty cool, if you say it. It's so tiny. It's actually invisible to the naked eye. So you see how you see it right now? In real life, you can't see it. It's so small and transparent. And those small things that you see popping out, these are eggs inside the body. You can actually see the eggs, the whole intestine. And who will pronounce this word? Cyanobacterius elegans? Okay, I'm gonna let that one go. So, this guy, he's one of my heroes, because one thing, he's from Africa. It's Sidney Brenner. He's an African biologist, so he also studied in Oxford University. So he was doing a research in which he found these small worms. And he was interested in them. They were transparent. They had male. They only had one male. And they don't have females. They have, hermaphrodite. How do you count that word? Sorry. Hermaphrodites. They have hermaphrodites. So he was interested, so he started doing research in them. So the hermaphrodites actually have a female and a male part. So that's why he was really interested in the fact that the entire body of this worm was mostly contained of neurons. So it's a special breed of species that he was interested in. So he used it as a model organism to study genetics and cell development. He won the Nobel Prize in 2002 based on the C. elegans research model. Technically, this organism is so small. It's a small nematode, and I know you guys know what a nematode is. Some of you guys do watch SpongeBob then. Its natural habitat is the soil, and it's 1 millimeter. How many of you guys know what 1 millimeter is?
It's less than a centimeter.
If I also put something as small as 1 millimeter, can you see it? Yeah, imagine if it's transparent. So technically you can't see it. That's camouflage for you. So all it is, it's E. coli. And I know you guys know what E. coli is. What is it?
Bacteria.
It's a form of bacteria. Yeah. And its life cycle for it to grow from childhood to adult is in 4 days. So that's pretty fast. They could actually start having babies within 3, 4 days, start making eggs. So technically the whole body of it is 1,000 eukaryotic cells and 300 neurons. You guys know what eukaryotic cells are, right? Yeah. Again, like not everyone knows, so I'm gonna go for her. Go ahead.
Simply put, it's the ones that many celled organisms have.
Yes, yep. But what is a eukaryotic cell?
It's one of the 2 different types of cells.
Yeah, well, the first one is prokaryotic, but I want you to give me a whole definition of a eukaryotic cell. Okay.
I don't know how to put it.
For students. Yes, you would agree.
So a eukaryotic cell is a cell that has a nucleus in it, so it has all the genetic information.
Thank you.
I have another question.
Yes?
Do the neurons, 300 neurons, count in the 1,000 eukaryotic cells?
It does. That's the best part. But look at what it says. It has the whole thing. It's 1,000, but approximately 300 of them are neurons. out of the 1,000. So it's part of it, but out of the 1,000 cells it has inside the body, 300, 1/3 of the whole species, consists of neurons. Your whole body, any organism doesn't have stuff like that. It's mostly, we have less neurons because our neurons don't regenerate. So all the other cells will have more cells in our body than our neurons, but this one has 1/3 of its body full of neurons. So that's pretty amazing. There you go, the hermaphrodite. So technically it has an X and X chromosome, and it has a male part and a female part. And technically they could reproduce by themselves without a male organism, or if they get interact with a male organism, they can still reproduce. And for the male, it has an X and an O. So you know most species, especially hens, they put X and an O, but for us we have X and X and Y. If you were to have X, Y, and Y, what would happen to you as a human being?
It's one of the different types of diseases.
Is that even possible?
Yeah. Yeah. Anyone?
Yeah, Down syndrome, right?
Triple X, XXY. You guys been doing genetics? I think the XXX is the one that you actually die from, and there's another disorder. I don't know if you guys saw, I was watching on TV that there was this guy who actually had, he was kind of half female and half male, but it wasn't fully, and then they found he has an XXY gene. It was in Indonesia, I think, I'm not sure, but I'll look into it. But it was pretty interesting though, just to learn about stuff like that. So, why do we use C. elegans? The reason was because they grow in 2 to 3 weeks. Like, would we want to use human beings who live for like 9 years? And we cannot use human beings. It's very illegal. If you do that, you will go to jail for the rest of your life. So you use animal models. Some people actually use it back in the days. Back in World War II, they were actually using Jews to actually do research on them. So technically, if you do that nowadays, you will be in jail full time. So in 12 hours, the eggs could actually go and become, the whole process of the fertilization and everything takes within 24 hours. For us, it would take at least up to 9 months before someone is born. So then it starts developing to adult stage between 2 to 5 days, and then the lifespan actually lasts for 2 to 3 weeks. Technically, this is the whole stage of it. It becomes embryonic development within 14 hours, and then the embryo starts growing, and it becomes larva stage 1 within 12 hours, and larva stage 2 starts growing. So technically, sometimes they jump, and they go to stage 4, which we call a dual larva. Some actually jump, and some just go through this 3rd stage and then go to the 4th stage. So this one sometimes will take several months because of the fact that they're born and they grow very slow. But these are the ones that we want. These ones, we technically discard them because we really don't need these. So then within 8 hours, they actually become an adult, and they can reproduce and live for 3 weeks. Like I said earlier before, and that was a mistake. It was not 300 neurons, it was 312. That was a big mistake, sorry about that. So 1/3 of it is neurons, and it has a simple neuron system anatomy. And what we just talked about, microstructures. And the best part about this is that you don't actually have to put them in cages. They could live in petri dishes, which is honestly just big. Thank you for rectifying my English, but that's my 6th step, actually 4th language. So the purpose of my research. So we're trying to determine the transcription factors BAF15